Welcome to October Symposium at CBER Forum. And my name is Hannah Halaburda, and I will be hosting this symposium today. And I just want to start by pointing out that CBER Forum has been established right from the beginning with the goal for interdisciplinary connection between researchers studying blockchain from different fields. So far, we have had a great success in bringing presenters from various fields like economics, finance, and computer science. But this is the first session that is focusing on the perspective of information systems. So we are going to have three researchers presenting in the order that I'm going to mention now. Semi Ming of NYU, Daniel Obermeyer from Technical University of Munich, and Ying Xie from Imperial College London. And just to kind of bring a broader perspective, the focus of information systems research is to look at how technology is affecting business, and how is it affecting the market, how is it affecting the market structure, but also how technology is affecting organizations. And of course, all those themes are intertwined, because if organizational structure is changing, maybe there are smaller firms, more firms, or fewer firms in the market, and this affects the market structure and then the competition. So clearly there is a overlap with economics and finance research, but at the same time there are some complementarities that I hope we're going to explore. So we're going to see this complementarity right in the first presentation. So Semi Ming is a PhD candidate at Stern School of Business at NYU in information systems. Her previous research specifically is exploring how smart contracts may affect the size of the firm. But what she will present today is the relation between the meaning of technology and how the market interprets technology, how the market sentiment is directed towards technology, and the adoption of technology. So for anyone researching or even just looking at blockchain and Bitcoin, we see that the market attitudes have been changing significantly since 2011 until 2021. And but a casual observer cannot really put a finger on when exactly they were changing, what are the patterns to this change. And this is what Semi is going to be showing us. And we should care about it, because those attitudes affect the adoption, they affect how the technology, which technology features are developed, and very importantly, they will affect the regulation aspect. So with that, Semi, please, I'm looking forward to your presentation, and go ahead, share your screen.
See, I will share my screen first. Yeah. So thank you very much for the wonderful introduction. And as she explained, I'm Semi Ming, and I'm a PhD candidate at NYU Stern. And I'm really happy to have a chance to share my work in front of the amazing audience here. And this work is the co-evolution of meaning and blockchain technology applications. And this research was inspired by the question of how emerging technologies are adopted into society. And I've been curious about why some technologies were developed a while ago, but it took decades to be widely adopted. There can be so many reasons why that happened, but I thought that perhaps one of the reasons is that it took a while for people to figure out the meaning of the technologies, such as what it is and what it is good for. So when the new technologies were introduced to the market, the narratives were produced around them to help people understand what it is. And interestingly, the contents of narrative changes over time as the technology itself also changing as it's diffused. For example, the label AI referred to an expert system in 1950s, but it now refers to machine learning or deep learning, which is very different from the old version of AI. So our research question is, how is the cultural meaning around the emergent and still evolving technologies produced over time as they diffuse in society? So to answer this question, we focused on an emerging technology which has been a hottest buzzword for about a decade, which is blockchain technology. And since its introduction, people claim that the Bitcoin, an application of blockchain, will replace the fiat currency and remove all the middlemen in our economic system. So like this blockchain technology was surrounded by interesting narratives, but it seems that people had a hard time understanding what it is. So as you can see from the figure on the right-hand side. Perhaps one of the reasons why blockchain is so hard to understand is partly because it's not a single technology. So blockchain is a general purpose technology which is associated with the technology applications that runs top of the blockchain platform, and their relative salience in the discourse has also changed over time. For example, an initial wave was driven by Bitcoin, but the people's attention shifted to the ICO investment, and then now people are talking about stablecoin used for the payment network. Maybe this is one of the reasons why blockchain is very confusing. But interestingly, despite such confusion, blockchain became eventually adopted by large institutions like JP Morgan and Facebook, who want to create their own blockchain and digital currencies for payment. So I thought that this is really interesting and became curious about how this was possible. So to answer this question, I studied theoretical perspective that explains the spread of emerging technology, focusing on the role of narratives or stories. And this theoretical perspective explained that the narrative can facilitate the adoption process by reducing ambiguity and confusion around the given technology by explaining what it is. And among this theoretical perspective, I draw on category perspective to analyze the data, which I will explain in the following slide. So the category research provides a very interesting insights about how we understand the word. They explain that when we see the product, we try to understand this product by classifying them into different categories. So during the categorization process, the shared meaning of a category provides a cognitive schema that allow people to easily understand and categorize a product. However, if the product is too novel and cannot be classified into any of the existing categories in the word, then people will have a hard time understanding what it is. So the category scholars explain that when the novel products are introduced, it's very important to create a shared meaning of a new category to help people understand what it is. Then how the meaning of the category can be created. So the category scholars explain that the meaning is formed through the connection to the other existing concepts in the society. For example, so ebook is different from the physical book, but it's called as an ebook and categorized as a book. And at the same time, ebook try to create a positive appeal by drawing on the symbolic elements like cultural value, saying that it's more portable and cheaper than the paper book. And this links around the label form semantic networks that determines the meaning of a category. And category scholars also use the notion of cultural codes to understand how certain technology gets to have a positive or a negative meaning in the society. So simply put, cultural codes are the value dimensions that have morally positive or negative meaning. And then these codes were associated with the categories to make certain category legitimate or illegitimate. And by associating these positive cultural codes around the category, then category can gain a legitimacy and become widely adopted in the society. So to understand how the meaning of the technologies are formed and evolved in the public discourse, category scholars often use the historical archival data containing a specific label. So following this tradition, I also scraped the news articles containing a label blockchain from 2013 to 2020. And overall, I collected around more than 240,000 articles. And as you can see, this societal level discourse consists of a huge amount of documents, which is impossible to read as a human. And therefore, qualitative research can only sample on a small set of data and then read and interpret them to gain some theoretical insights. However, because of the sampling process, scholars can sometimes miss very important part of the story. So we thought that researchers may, especially who are studying societal level dynamics, can benefit from the new methods dealing with the large scale data. Therefore, I developed a method to conduct a mixed method study by combining computational methods to support the analysis of evolving meaning structure around the blockchain. So throughout the research, I follow the grounded theory approach and then use this method listed here. And I will go over each of these analysis and show you what I found from the data. So first, after completing the data collection, I ran LDA topic modeling algorithms to our data set and identified 70 topics from the documents. And after this, I plotted the historical distribution of topics, aggregate distribution per 6 months. And the result looks like this. As you can see, the distribution on the right-hand side shows that the topics are dominant in different stages. And also, if you look at the topic here on the table, you can see that these topics all have different set of vocabularies. So I found that this pattern is really interesting, but I could not explain why this pattern appeared in the corpus, right? So I found that the qualitative reading is a necessary step to understand the overall storyline. So what I did was sampling 20 representative documents for each topic, which shows the highest topic distribution. And after that, I read and coded these documents to interpret the meaning of the given topic. And at the same time, when I was reading the documents, I realized that the different phases in the topic distribution can be explained by the changing cultural values associated with the technology applications and uses. So I did focused coding to identify the cultural value related to the technology applications. And then I developed a qualitative story through memoing and writing narratives. So here, as I explained earlier, I paid particular attention to the value characteristics like fast, which is associated with the technology applications like ICO. And then I also interpreted the meaning of the topic by looking at the vocabularies and the reading of the representative documents. And in this process, I realized that many of the topics are broadly grouped into the technology applications and technology uses in diverse contexts. So I classified the 70 topics into these two categories. So by focusing on why these changes in topic structure happened, I identified the 3 stages from the data. And I found that the 3 stages are demarcated, especially when certain technology applications and uses gets to have a negative meaning in the society. And in response, the new technology applications appeared through the innovation, and they start to propose different set of positive values. So from now on, I will give you a brief overview of why these technology applications were stigmatized and what happened after this event. So the Mt. Gox was the world's largest Bitcoin exchange, handling over 70% of the Bitcoin transactions worldwide. However, suddenly, like the Mt. Gox closed its website and filed bankrupt in 2013. And it was found that the more than 450 million worth of Bitcoin disappeared from the exchange. And the company said that the exchange is attacked by hackers, but later it turned out that it's not true because the CEO of the Mt. Gox directly stole the money from the exchange. And even before the Mt. Gox bankruptcy, problem has been accumulated around the Bitcoin associating negative values with the blockchain category. For example, miners colluded to manipulate the ledgers, cyber attacks were repeated in the blockchain exchange, and Bitcoin were used for illegal activities like drug dealing. And Bitcoin price became so volatile as more people jump into speculative trading. So over time, Bitcoin became increasingly viewed as risky and corruptible concept, and then that leads to the innovation in stage 2. So after the Mt. Gox event, the new applications emerged, promising a new set of positive values. And then the most representative application was the ICO token. So ICO was described as an alternative fundraising method, which is efficient and democratic. So if ICO were viewed as more efficient than the traditional IPO, which was known to be slow and complicated and expensive. And ICOs were viewed as democratic because they allow everyone to participate in the venture capital investment, which was historically only allowed for the large financial institutions like hedge fund or venture capital. So with these narratives, ICO gained huge popularity from the individual investors and the startups. However, over time, ICO investment again associated with the set of negative values like with the blockchain And for example, the rush into ICO investment created a huge bubble in the ICO market, and the lack of regulation made ICO fraudulent because startups often write first and misleading information in the ICO white paper to sell the tokens to the unknown investors. Finally, SEC, like the regulators, stepped into an ICO market and announced that the ICO will be regulated as a security if there is an expectation of the profit. But interestingly, after the SEC's intervention in stage 3, the new concept security token emerged as a fully regulated version of token. And the discourse particularly emphasized the advantage of security tokens, saying that it's safe investable asset compared to ICO or Bitcoin. As a result, institutional investors became viewed as an alternative asset class. As a result, large institutions also began to invest on digital assets and experiment with the stablecoin. And the players like JP Morgan create their own blockchain and the stablecoin called the JP Morgan coin. And also Facebook published a white paper announcing that they will create a stablecoin called Libra, which later renamed as a dime. So based on this analysis, I found that the significant shift in the meaning structure occurred, especially when the negative value characteristics were associated with the technology applications like Bitcoin and ICO. And again, this set of negative value characteristics can influence on the high order meaning of the blockchain category, like the general category, which ties again, like multiple technology applications and use context together. So to resolve this problem, like the new technology applications and uses were proposed, producing a new set of positive value characteristics. And this way, the meaning of the blockchain category can also be changed to the positive direction. So through this repeated process, the blockchain can sustain the collective attention from the public and continue its adoption process. So far, we've seen that the association between value characteristics and technology applications and uses shapes the meaning of the blockchain category and the emergence of new technology applications, right? From now on, I will do more systematic analysis to understand how these value characteristics provides a positive or negative meaning to the category using semiotic chain analysis. So the semiotic chain analysis is a method used to study how a certain concept gets to have a positive or negative meaning in the society, generating some sort of emotional appeals. And this technique identifies the denotative and connotative relations in the text. And the denotative relations refers to the association between the specific objects or practices and the elements of the cultural codes. For example, in the news articles, Bitcoin is often described as a speculative, volatile, vulnerable, and unregulated concept because of the bad accident around the Bitcoin. And this is called denotative relations. And the connotative relations connects this lower level value characteristics to the broader level, like the cultural opposition or the sign system. Here, these four elements are associated with the concept of risky, which is in general have a negative meaning in the society. So through this structure, hierarchical structure, Bitcoin became associated with the negative meaning of risky in the public discourse. So in order to conduct a semiotic chain analysis, I first identified the cultural codes by forming oppositional distinction using the value characteristics. And then I identified the four key value dimensions based on the grouping of the similar cultural codes. So as a result, I identified a four key value dimension of efficiency, safety, incorruptibility, and egalitarian. And then I did some exploratory analysis to understand the relationship between the technology applications and the value dimensions. And the result looks like this. So here in the figure, the upper part shows the connotative relations, while the lower part describes the denotative relations. And then I conducted a computational longitudinal semiotic chain analysis to map how cultural codes associated with the given technology applications evolved over time. So for this, I used the word embedding. So in the word embedding model, each word is represented as a vector, and this vector can be projected into a multi-dimensional vector space. And in this vector space, the word have similar meanings are located closely in the similar place. And the distance between the word can be calculated using cosine similarity, which means the angle between the vectors. So in order to identify the evolving relationship between the technology applications and values, I trained historical word embedding. And historical word embedding is a very useful tool to study how meaning of a specific word has changed over time, changing its association with the other vocabularies. For example, as we can see from the figure, the word game meant sweet and cheerful, but it shifted its position over time and became associated with the words like bisexual and homosexual. So building on this work, I divided the corpus into temporal slides and then trained the word embedding for each subset of corpus. And our next step was extracting the value dimension from each subset of corpus using the group of terms having oppositional meaning, in this case, for example, safe and risky. And once I extracted the dimensional vectors that ranges from the hyper risky and hyper safety, and I used this subtracted dimension as an axis in the vector space and projected the other terms along the safety dimension. And the projection can be done by calculating the cosine similarity between word vectors and the extracted dimension, according to the prior literature. So I projected the technology applications associated with the label blockchain along the value dimension of risky and safety, and then saw the location of each of the vocabularies. And then we can also add another dimension such as incorruptible and corruptible, and then project those technology-related terms onto this two-dimensional space. Also, we can visualize the relationship between technology applications and the different elements of cultural codes using the graph like this. For example, if you look at this figure, the high value along the vertical dimensions means highly immutable, while the low value means highly fraudulent. So in this two-dimensional figure, I projected the terms along the value dimension of risky and safe, and corruptible and incorruptible, right? And to see that, I did it to see the historical changes in the meaning of the technology applications. So if you look at this figure, you can see that Bitcoin has generally negative meaning, positioned as risky and corruptible. As I explained earlier, the bad accident around the Bitcoin space associate these negative meanings with the Bitcoin concept. However, after the Bitcoin became stigmatized, the new technology applications like ICO emerged in the blockchain space, promising the new set of values like efficient and democratic. And in contrast, Bitcoin moved its position over time, being increasingly positioned as inefficient and centralized. And the blockchain term is somewhere like located here in the middle and do not have a very clear meaning in the public discourse. However, because of the bad accident in the ICO market, ICO became increasingly described as a corruptible and risky concept, shifting its position over time. And interestingly, at the same time, blockchain label also shifted its position together, meaning that the meaning shift of the ICO could affect the meaning of the blockchain label too. And after the SEC stepped into a market to regulate the ICO investment, the security token emerged and positioned itself as a safe investable asset. So the STO, which stands for the security token offering, replaced the ICO's initial position and were described as a safe and incorruptible concept. And then the blockchain also shifted its position over time, being viewed as safer concept. And finally, stablecoin, which is the type of security token like adopted by large institutions like JP Morgan and Facebook as a medium of payment. And as a result, the blockchain can achieve the the institutional adoption. So to summarize, blockchain is the label that ties multiple technology applications together. That means blockchain is the general purpose technology, pretty much like an internet that has so many different technology applications that runs top of its platform. And then the meaning of this general purpose technology can be understood through the use of technology applications in various contexts. And the shift in the meaning of the blockchain category appeared when an existing technology applications became associated with the negative meaning after a certain event. And also when the new technology applications and uses were developed to associate positive meanings with the technology applications, and also to the general, like a higher level blockchain category. So I bring this emergent finding back as a theoretical model. So here, the technology applications and uses can be captured through their placement and at the dimensional space, which is determined by their association with the value dimensions, which has a set of different, cultural codes having oppositional dimension, right? And the value dimension and their association can be calculated using cosine similarity. And these values, again, shapes the meaning of the category, which can be also captured by the placement of their location at the dimensional space, which I showed you earlier. And then the meaning of technology applications in use context can shape the meaning of the general category. So these are the theoretical takeaways. To summarize, blockchain applications and meanings co-evolve during the diffusion process. And the general purpose technology like blockchain can often have a very ambiguous meaning in the early stage of their development because it's associated with the various technology applications, and also it's a hidden layer of the not being seen by users. And the meaning of the general purpose technology gets defined and redefined through their discursive action and the use context. And so overall, the constant reconfiguration of the meaning and technology reach different value compromises as they as the diffusion process unfolds, right? So it is true that the general purpose technology often have a very confusing meaning in the early stage, but despite such confusion, creating one or more killer applications like Bitcoin or ICO can fuel its adoption process and sustain the collective attention toward these technologies, right? So thank you very much for listening, and this is all end of my presentation. Thank you.
Thank you very much, Semi. So we have a couple of questions. At least couple that are very related to your presentation, and I will unmute first Will and then Jerry. But before we unmute them to ask their questions, I will answer Daniel Treku's question about whether the video will be shared online. The plan is to share the video online. So it is all very interesting, and if you want to take another look, it will be posted later on. So Fahad, can you unmute Will so that he can ask his question about about your procedure?
I'm already unmuted. Thank you.
Okay.
Just a quick clarification question. You chose the 70 topics. Is that something you pick yourself, or the data is endogenously showing 70 topics? Because for topic modeling, that parameter matters quite a bit in terms of how interpretable
right.
the results.
Right, so the 70 topics are not determined by myself. I use the algorithm called the coherence score, which is conventionally used by, like the organizational researchers and also other people who are using LDA topic modeling. So I run the multiple topic modeling by incrementing the size of the topic by 5, and then chose the topics that shows the highest, the number of topics that shows the highest coherence score, and that was the 70 topics. So that number was determined by this coherence score algorithm.
Got it. Thank you.
Okay. Yeah.
Thank you. And Jerry has a different question.
Yeah, I mean, so
Jerry. Yes. Jerry,
can you hear me?
Yes.
Okay, thank you, Semi. This is really fascinating work. I just had a quick question about the term DeFi, because that seems to be in the news a lot, or maybe I'm biased. I keep reading for the last 6 months all about DeFi, the revolution DeFi is causing. It doesn't seem to pop up from your analysis. I'm just wondering if you had any thoughts.
Yeah, I thought that it's very interesting that I also expect that the DeFi will come out from my analysis, but the topic modeling that I run from the, using this data doesn't really show the clusters that characterizes the DeFi. So which I thought that it's really interesting. Maybe we are biased because it's a very recent topic that are, and then a lot of people are talking about it, but it's a very recent topic. So when we see the historical data, it doesn't really yet, popped up as a important, cluster. But if I collect more data, especially which was published in 2021, then I'm pretty sure that the term DeFi will pop up in my analysis. But my data collection ended at the 2020, so I couldn't see that.
I see. Yeah, that makes sense. Thank you.
Okay. Yeah.
Great. So we have some more questions, but I will, Semi, I will let you answer it in the Q&A box, and we will move to the next presentation to stay on time.
Okay.
So our next presenter is Daniel Obermeyer from Obermeyer. I'm sorry, Daniel Obermeyer from Technical University of Munich. He's a PhD candidate there in information systems, and his research, his projects, and multiple projects, evolve about new marketplaces that are created or enabled by smart contracts. And we would think about smart contracts as this very democratic tool that allows for anyone to inspect the quality of smart contract, and therefore will allow for democratic interactions in the market. Now, it turns out that even though smart contracts are visible on blockchain, it is not enough for people to reliably inspect them. And this actually creates frictions in the markets that are just as new as the market itself. So I guess what Daniel will present now is how these new frictions create room for new markets. And Semi, if you could stop sharing your screen so that Daniel can start sharing his, would be helpful.
Okay. Thank you very much. Let me try to share my screen. So now it should be loading, and now you should be able to see my screen, right?
Yes, we see your screen, but we kind of hear you like from very far away.
Okay, then I just will move closer to my
yeah,
laptop.
I think that fixed it for now, because
Okay,
I know
so
it would
speak directly into the microphone.
Yeah.
Okay. Super. Thank you very much, Hannah, for this very wonderful introduction, and thank you also to the organizers of this CBER Forum. This is really a very great symposium with so many inspiring presentations so far, and I'm really happy to be invited here and to give also my presentation and present my topic. So the title of the presentation is Smart Contracts on a Blockchain, Transaction Governance with the Potential of Deductive Certainty. And this work is co-authored by my advisor, Joachim Henkel. So I myself, as Hannah mentioned, I'm Daniel Obermeyer, and a fifth-year PhD student at the Technical University of Munich, but right now I'm visiting Hannah as a visiting PhD student. So to talk about this topic, maybe the title sounds a bit cryptic to you, especially if you don't have this background of management and maybe governance research. So let me break it down to you a bit what this is all about. So the question we are actually trying to answer with our research is, how do users decide to interact with a decentralized application? And here we do not mean so much what kinds of applications do users like. We are more interested in what are the mechanisms that convince people that it's safe to transact with a decentralized application. And to answer this question, we take the perspective of a governance mechanism. So we are not so much interested on the governance of the blockchain, so how the protocol itself evolves. We are very much interested in the basic mechanism that governs a single transaction. And to provide you with a definition of what governance actually means against the backdrop of our paper, we specify a governance mechanism is something that specifies the rules of a transaction and how these rules are then enforced. So in other words, a governance mechanism allows users or transacting parties to form some level of certainty about the transaction. Therefore, based on the level of certainty they get about the transaction, they can decide if they want to interact with it or not. Based on the prior literature, but also very much from our daily life, we know two types of governance mechanisms. So contractual governance, simply here we have rules of the transactions written down on paper most of the time, also digital nowadays, which are then enforced by law in front of a court. On the other hand, we also know relational governance. Here we have more oral agreement, which are then self-enforced by trust and norms, which arise from a pre-existing relationship. In 2020, Lumineux and his co-authors introduced blockchain as a new type of governance mechanism. Here we have smart contracts as the rules of the transaction. So the smart contracts specify in written computer code all rules of the transaction. And these rules are then enforced by a decentralized set of machines. The difference from blockchain governance to contractual governance is now that we already have all the execution mechanisms specified in the very same code of the smart contract. And this is something which really sets it apart from contractual governance, because in contractual governance, you have some rules specified in the legal contract, but then the rules of the enforcement, they are subject to the law and specified somewhere else. So this about the basis of governance mechanisms. Let's now have a look how they actually work in practice. So therefore, I looked up some application on the App Store. And this is a simple gambling application. It's called Pocket Lottery app. And there you can just do some gambling games. This application runs very much on relational governance and contractual governance. For relational governance, you can either rely on 53,000 ratings, which the app has received, look up how the users perceive that application, or you can also look up where the company is located, and you would also have some information about the founders. Based on all that, you can assess the trustworthiness of the application and decide if you want to interact with that. Further, Checkpocket also provides some contractual governance for you to decide if you want to interact with it. Simply, it is based on, runs on an official gambling license, is issued by some state. And then before you want to do a transaction with Checkpocket, you need to sign a legal contract. And I actually looked that up, and it's around 28 pages long. So quite some contractual governance which is going on here. If we now move away from the App Store and the typical way we are used to interact with applications, and we come to the crypto space or the blockchain space, we have a very similar application here. It's a decentralized application, and it's called Ethereal. Again, here you can gamble. The difference, however, is that it does not rely on relational governance and also not on contractual governance. Simply because you do not know who's running Ethereal. There is no information about the authors of this decentralized application. So you cannot rely on any relationship to that decentralized application or to the persons behind that decentralized application. And to make it even worse, we even do not know if Ethereal is a legal entity and where it is based. So you cannot rely on contractual governance, because good luck with suing someone where you do not know where the company actually is. However, at its peak, Ethereal was able to attract 5,600 monthly users and offer also $3.1 billion in wagers. And that's something interesting because we cannot explain that with existing governance mechanisms. So the question arises, how has Ethereal been so successful in establishing that many exchange relationships? To some extent, they explain it or try to explain it on the webpage. They claim they are provably fair due to the nature of the Ethereum blockchain. So they claim that they rely on two important properties. The first one is immutability of the smart contract. So the rules need to be predefined, and then on the automatic execution of transactions. So for us, this means all conditions and actions of the transaction with Ethereum are predefined in a smart contract. Further, once the smart contract is then deployed to the blockchain, nobody can change it anymore. And also nobody can interfere with its execution. So once you send money to Ethereum, the decentralized network will execute the smart contract as specified on the blockchain. And that basically allows users to comprehend all the mechanisms of the transaction, even before the transaction takes place, and allow them to determine the outcome of the transaction also before it takes place. And this is something new we have here, because users can go through the mechanisms by pure logic and deduce. So this is a deductive process, the outcome even before it takes place. Of course, they cannot determine if they've won the lottery, even though with some application that was actually possible. But in a way, they can check at least if it's fair. And since that all has to be done by pure logic and by means of deduction, we refer to this certainty they can obtain as deductive certainty. And if this deductive certainty is reached, then trust in the other party becomes dispensable. So they do not need to trust the other party in order to decide if they want to interact with that. And we find exactly that claim quite often in the decentralized application space. So you will find applications from every category claiming that they are trustless, and you do not need to know the company behind that simply because you can read the smart contract. But is it actually simple like that? I would say not really, because another truth is this is what a smart contract on a blockchain looks like. I suppose many of you know that on the blockchain, at least in Ethereum, only the bytecode is stored there. And arguably, not a lot of people can read what's written here. However, it's also a deliberate choice of the company offering the decentralized application to actually verify the source code of their application and show by a technical way that the source code they've published and verified that this is the same as corresponds to the bytecode which is running on the blockchain. And they do that via some third-party platform, here, for example, the Etherscan. And after they've done that, then people can actually look up the source code. This is something we can read if we can read Solidity, go through the source code and understand step by step what it's really doing. However, and you see there are a lot of these howevers, it requires a lot of effort and time and obviously skill to actually do that, to read it and to obtain deductive certainty. And this leaves us with a very interesting trade-off. So on the one hand, deductive certainty is possible if the source code is available and if it's verified. On the other hand, due to high costs of obtaining deductive certainty, and this is something we know from the literature on information processing, people may use heuristics rather than trying to get this full certainty. And this again leaves us with a question: how do people decide to engage in an exchange relationship with a decentralized application? To answer this question, we take an epistemological perspective on governance mechanisms. And that word epistemology might sound a bit weird to some of you, but it's fairly simply explained. This is just the way in which knowledge is created. And there are basically two main processes how we create that knowledge. I mean, there's also a third one, but we only focus on the two main ways. The first is an inductive process. So that you form some expectations about the trustworthiness of the other party, and because you have some expectations about the trustworthiness of the other party, you can form expectations about the outcome of the transaction. And you would usually do that if you look at the example of the application we had, which was a Jackpocket lottery. So you look up the founders, you maybe think they're good looking, maybe the website looks kind of nice, and therefore you think they are trustworthy, and therefore you form some induction related trust. This trust, however, does not tell you anything about the transaction mechanism itself. So it never gives you certainty about the outcome of the transaction. And this is usually the kind of trust we have in all established trust formation models where we rely on an existing relationship. It tells you some, or gives you some experience, but it does not really reveal the mechanism of the transaction. This is actually something which smart contracts can do, and therefore they enable a new way to form trust. And this is by a deductive process. As I mentioned before, this is pure logic. So based on the possibility of deductive certainty, so that you can go through the source code, read it and understand it, you can also form trust. Because if you do not read the whole source code, but some parts of the source code, you can already form some expectations about the outcome of the transaction. Even though it's not certainty, you can form some kind of trust. Or maybe you rely on some other party which has done this deductive process and told you that it's without mistakes. Then you would also not have certainty for yourself, but some deduction-related trust. And this is exactly what we claim in our paper. Smart contracts are a new way to form trust because they allow to form both. On the one hand, since it's a normal web application in a way, you can form induction-related trust. But the new thing is that you can also form now deduction-related trust. To test our theory here, we are developing some hypotheses, and they are pretty much straightforward. So on one hand, deduction-related trust queues should have a positive association with the decision to enter an exchange relationship with a decentralized application. So to send transactions to the decentralized application. On the other hand, also induction-related trust queues should have a positive association on the decision to enter a relationship. To disentangle both effects, we use two moderating variables. The first one is risk. Here we hypothesize that risk has a positive moderation on both association. Simply because the higher the risk associated with a transaction, the more you're looking for trust queues, no matter from what side they come. And on the other hand, next to risk, we use the cost of obtaining deductive certainty. So basically, how much effort does it require to read the source code to differentiate both effects, or hypothesis 1 and 2? Because here our argumentation is the higher the costs, the less likely it is actually that you will rely on a deduction-related trust queue simply because you're maybe not willing to read parts of the source code. However, then on the other hand, if you don't read the source code and you do not want to form deduction-related trust, you need to rely more on inductive trust queues. And that's why we expect a positive moderation of the second association and a negative moderation of the first association. This about our hypothesis. To test these hypotheses, we collected a novel data set of 536 decentralized applications, and we used different data sources. All these applications are currently running on the Ethereum blockchain, and we collected them from State of the Dep, and then added some more data from Etherscan and directly also from the blockchain. Further, we also added some more data which we got by hand rating trust queues provided by these decentralized applications. So basically going through all the web content provided by these decentralized applications and rating what trust queue they provide us with. If we look at the dependent variable, we are interested in a number of unique relationships. So in a way, the users of a decentralized application. And for the independent variables, we have two types of independent variables. For deduction-related trust, we use a dummy variable which indicates if the source code is available and verified. And we do that because this is the most important thing. Only if the source code is verified, then usually only then users can look it up, read it, and form this deduction-related trust. On the other hand, for induction-related trust, we use a set of different measures. As I said before, we went through all the web pages and rated trust queues. And we took these trust queues from the literature on trust formation, and then basically went through the web pages and rated all of these queues. Since there's, of course, a lot of correlation going on, we ran some factor analysis and summarized them into one factor. For the moderators, we measure risk in terms of financial risk, so the money you need to send to a smart contract to trigger it. And for the cost of obtaining deductive certainty, we simply take the lines of the source code. And then finally, we control for a set of different variables and run also multiple robustness checks. If we now look at the results, the already first interesting thing is that we find support for both our main hypotheses. And this is interesting for two reasons. So first, it shows that smart contracts really offer something new, the verified source code, and people care about the verified source code. And that can be the first indication that they actually want to rely on this deduction-related trust. On the other hand, it also shows that induction-related trust queues apparently still matters to users. And that can be a first indicator that smart contracts are really not trust-free, because people still want to have some of the established trust queues they can rely on. For H3, we also find some support. For H4, we expected a positive moderation, however, could only find a negative one. And one possible explanation for that could be, so the higher the transaction value, the more likely you actually are to read the source code. That pretty much aligns with hypothesis number 3. However, if you have read the source code or some parts of it, you're closer to this deductive certainty, and therefore you need to rely less on deduction-related trust queues. But this is just one possible explanation, and this needs to be backed by further research. For hypothesis number 5, this is something we unfortunately cannot measure due to our data set, and for H6 we don't find any significant results. However, at the end we also checked for complementarity between deduction-related trust and induction-related trust, and we indeed find complementarity here. And this is again interesting because we interpret that in a way that we say smart contracts are not trust-free. However, they provide us with a new way to form trust that actually complements established trust formation mechanisms. And that could be interesting because that would allow smart contracts to enable some transactions which would have not been possible before if you just would have relied on relational, induction-related trust queues. However, looking at these results, I think the elephant in the room really here is, do people read the source code? This is something we cannot prove with our data here, simply because we take a dummy variable which indicates the source code verified, yes or no. And I think this is also very much mirrored by this quote from Jamie Dimon. And thank you very much for Javi, who's hopefully among the listeners, for giving me this quote here. I think it fits quite nicely because Jamie actually questions if the users in the crypto space who are really hyped about all that stuff, if they really read their algorithms. And Jamie is really skeptical about that. And so were we. However, we thought we could do something about that and look into that more closely. And what we did in a second project is then we developed our own decentralized application, which is a survey tool like SurveyMonkey, just with the difference that it's running on the blockchain. And that allows us to send out surveys to users of decentralized applications, because you can only participate in the survey if you have received a token to the survey. And now we conducted a survey with users of decentralized application where we asked them how they form trust in decentralized applications. And we received 97 answers to our survey, and we asked them a lot of different questions. However, I will only go through the most important ones, which also speak to our first project. So the first question was, do you care about the source code of the decentralized application is publicly disclosed and verified? And as you can see here, for the majority, it is important or even very important that the source code is verified. Again, we could say yes, but that's signaling. However, then we moved on and asked them also about the reason why they want to have a verified source code. And one of the reasons we asked them about was, do you actually want to read the source code? And as you can see here, there are quite a lot of people who agreed with that, and they told us that they really want to have a verified source code because they want to read it. Again, this doesn't tell us to what extent they read it. And so we moved on and asked them also, to what extent do you read the source code of a decentralized application? And the interesting thing is here, of course, not all people are reading the source code, but we can see that there are quite a lot of people who at least skim over the source code or try to obtain a basic understanding about the functionality of the source code. What we can also see here, that only few people obtain an in-depth understanding of the source code, and even fewer people really check for security weaknesses in the source code. So what we basically can see here, not a lot of people obtain deductive certainty and have real certainty about the outcome of that transaction. It's more likely that people just obtain some understanding of the smart contract and basically form some deduction-related trust. And I think our study number 2 actually provides some more evidence to the claims from our study number 1. To sum it all up, our work is limited by endogeneity concerns, simply because smart contract verification is of course not random. Then the generalizability might be a problem because we're still in the kind of developmental phase of the theorem. So the early users may differ from the later majority. And then finally, also at the end, since we're using cross-sectional data for the rating of the trust queues, the reference time of the data might be an issue. However, the next steps for our projects are, we want to finalize the first project by working on the framing, shorten some sections, and then make it ready for submission. And for the second project, we will conduct a second wave of the survey to increase the sample size, but also to have another point where we collect survey data to make sure that our first collection was not biased by some event during the collection period. To sum it all up and to give you some takeaways from my talk here, I think the first thing we learned is that smart contracts are not really trust-free, and that just having a verified source code will not cut it. So just claiming that you have a verified source code and they say you are completely trust-free, that might not help you to attract a lot of users. On the other hand, we also learned that smart contracts allow to form a different kind of trust that complements the traditional induction-related trust. And this is interesting, as I mentioned before, because that can help to establish or to enable transactions which would have not been possible before. So for example, if you want to do a transaction with a company which is in a country where you don't trust the legal system, so relying on relational and contractual governance is not completely possible, then smart contracts could help you out to supply a different source of trust, which then helps you to do these kind of transactions. Finally, at the end, what we've also seen, not a lot of people read the source code to the extent that they can find out mistakes in the source code. And this makes them vulnerable to some scams or bugs in the source code. And therefore, we will see that it's maybe likely, and I think we have seen some of these companies already being founded and getting up to work, that we see more auditing companies as a new intermediary who really go through the source code and provide us with certificates so that we can rely on their deductive process. I think that's the end for my talk. I hope you could take away some more understanding about the potential of smart contracts, and now I'm looking forward to your questions and some feedback. Thank you very much.
Thank you, Daniel. We have one question from Maria. I guess, Maria, you should be unmuted now.
Yes. Can you hear me?
Yes.
Yes.
Great. Thank you very much, Daniel, for a wonderful presentation. A lot of interesting thoughts and insightful results. So I've been just wondering, what is the statistical distribution of the verified code on the Ethereum blockchain?
Mm-hmm. I mean, I also have that in our data, and if you want to see that more precisely, I can show it to you later, also offline. So we have like 40% of the applications which really verified the source code, and the other 60% did not verify the source code. But I also need to mention that this was like 1.5 years ago that we collected our data, and this may have changed right now. So people could have found out that it's important that they verify the source code, and now way more applications verify their source code. Even though we also have to mention that it's a bit tricky to find out what kind of smart contracts are verified or what decentralized applications, because as you may know, some of the applications run on multiple smart contracts. And some applications like CryptoKitties, for example, they have some verified source codes, but they also deliberately chose to not verify some other source code or some other smart contract source codes they're running on, simply because they want to hide some of the functionality. So therefore, in our sample, we restricted all decentralized applications, and therefore we only have 536 all applications to applications which run based on one smart contract, because then we can see, do they verify the source code or do they not verify the source code?
Great, thank you very much. And just one comment and question, actually. So do you notice any temporal dependency that after some point, majority of the DApps have the verified source code? And related question, do you see any change in the policy of Ethereum that the verification becomes a requirement for all smart contracts published on the platform? Thank you very much.
Also very, very interesting question. So far, I've not seen that it becomes a requirement. And also, we asked the question in our questionnaire if like users perceive that as a de facto standard, they want to see the verified source code. And here people also answer that they do not really see that as a standard. And I also talked to some of the developer, and they also mentioned it's not really the standard, but still a lot of people are doing that. Regarding the time thing, as I said before, more applications are now verifying their source code, and I think also in the DeFi space, a lot of applications do. But as I mentioned before, some also deliberately choose not to do that. What we also looked into was basically when do they verify the source code? And here we could find either they do it at the very beginning, or they don't do that, and that's also kind of important for our study.
Great, thank you very much.
Thank you, Maria, for the questions, and thank you, Daniel, for the answers. Daniel, there are a couple more questions, very cool questions in Q&A, but I will leave you to answer it insert them in the box. Oh, Joachim, you have a comment. We cannot hear you.
On my side. Am I still muted? Oh.
You are unmuted, but I think it's also a microphone issue.
Yep.
Yeah, now I can hear you. So yes. So maybe if you are close to the microphone, we can hear you.
Now you can hear me even better.
Now it's even better, yes.
Better microphone. So first of all, thank you also from my side for the opportunity to present. Just a little addition from my side. I've done research on open source software and on Linux and on drivers for Linux. And it's a bit similar that drivers disclosing the source code for Linux drivers is very much welcomed, but it's not the norm. And what I found in earlier research with colleagues is that they would often not do it when there's confidential stuff in there, or really when it's kind of differentiating. And we may assume that that may also be the case here. So there are reasons for not disclosing, and which speaks against 100% disclosure. Anya, you correct me if that's wrong. Thank you.
Okay. Thanks, Joachim. So I think we need to move on to the last presentation we have, so that Ying has enough time. So the last presenter for this symposium is Ying Xie. She's a faculty professor at Imperial College London. She is also a co-director of the Center for Cryptocurrency Research and Engineering. Her extensive body of research centers around decentralized organization and the governance of decentralized organization. So it's very, very much appropriate for blockchain. And especially today, she will present the comparison of decentralized organizations and platforms. So blockchains are kind of by nature platforms as well, but they are very different than the traditional platforms that we know from earlier, where they are centrally governed, and many blockchain platforms are governed in a decentralized way. So Ying, I'm looking forward to hearing your thoughts on that.
Thank you, Hannah. Let me share my slide. Can you see it? Yep. Cool. Hello, everyone. My name is Ying. I'm very excited to be here to talk to the community of blockchain researchers, cross-disciplinary one specifically. Like Hannah said, I focus on the organization design of blockchain-based implementations, but more broadly, decentralized platforms, decentralized organizations, and I focused on the coordination and the governance of this extremely decentralized form of organizing. So as we all know, platforms like Facebook, Google, or Amazon are classic examples of proprietary platforms. They have been extensively studied by the platform literature in terms of how they orchestrate their strategy of different participants to achieve financial performance or the growth objective. So now today we're going to look at, now why is it not moving? Okay. We're going to look at a different type of platform, which is a decentralized platform. You may be thinking corporate governance, but that's not really what we are looking at today. And decentralized platforms or distributed systems are not new. The closest one to blockchain is probably the internet, which was so we built in the so the personal computer was created in 1944, but it wasn't until 20 years later when computers started to talk to each other in a network. Okay, so simply put, how do we govern a system, a distributed system that is probably similar, somehow similar to the internet, that is not owned by a corporation nor controlled by a management team? So we don't have a Bitcoin Corp. We don't have a Bitcoin CEO, but the fact is that if you look at the growth of the cryptocurrency industry, it's phenomenal, right? And if we want to go back further in time, we are looking at this Victorian internet, which again was quite centrally controlled, centrally owned by the British government now back in the late part of the 19th century up to World War I. It's still highly concentrated. So what kind of network is blockchain, and how is it going to evolve in terms of its governance? What is unique about decentralized platforms? And here we are mainly looking at ownership and the control. So the two central elements of any corporate governance, right? Even in the traditional sense. We're just bringing the level of analysis up to the ecosystem level. Additionally, with digital platform, because it's enabled by technology, it's arguably more generative in that ecosystems have the capacity to create value in complementary ways through unfiltered contributors. So anyone can join and leave at will. So these unprompted changes support platform configurations and designs in a more dynamic way, and this is really what makes ownership and control on the blockchain-based system different and in my opinion, very exciting compared to traditional platforms. Okay, so very quick identification of gaps in the literature. Again, I am looking at the platform literature here. Some of you may be familiar with this literature than, or more familiar than others. So let me just quickly go through the gaps and the why my research question is interesting and relevant. So like I said, mostly in the literature, when we look at ownership, we study highly concentrated ownership with these corporate platforms like Facebook and Google. There is a literature looking at distributed ownership, but we really have, we still have relatively very little idea about how the ownership structure affects the outcome. In terms of control, similarly, there is a small literature looking at distributed control, specifically at the for the community-based governance setting. However, we don't really quite know what options we have in terms of distributed control, how decisions are made, and are there different types of distributed control that are available for community members in the toolkit. And the third point is really how do ownership and control interact with each other to either enhance or hamper the outcome. And by outcome here, I'm looking at the returns. And it's a typical sort of outcome measure for governance. And the fourth gap, which I think is very interesting and is highly relevant to the blockchain context, is the performance measure. So how does one measure all the economic activities taking place on the internet? We don't really quite know because they happen like across the globe, and there isn't really an internet token that's readily available there for measuring the financial outcomes. But we can do that with a blockchain-based platform. We can measure the GDP of a crypto economy, and that's very exciting. Okay, so although platforms are set to facilitate joint value creation, but we haven't really been able to measure that value created. So far, platform studies have been rather one-sided, and that's understandable because you can either really look at the complementers, people who build products or services on the specific platform infrastructure, or the platform providers' performance, but you can't really, we haven't really been able to take a more holistic view at how the value is created. Okay, so these gaps motivate my research question, which is how does distributed governance enabled by varying degrees of dispersed ownership and the different types of decision control modes to affect performance? Okay, so the ownership now can range from 0 to 100%, and the different control modes I will show you later, which I identified the three bigger categories of blockchain-based control. And to answer this question, I studied 93 blockchain-based decentralized platforms from 2017 to 2020, sponsored in various degrees. By sponsored, I focused on organizational sponsorship more specifically. So organizational sponsors include companies, foundations, or teams. These sponsors, they usually go for 3 decision control modes based on a combination of token-based voting and the delegation. So here, the first criteria by which I look at control is coin-based voting. Okay, and the 2 broad categories, now you can see here are on-chain versus off-chain. I think most of us may be familiar with the difference here. So by on-chain, token owners will be granted control rights, right, to make decisions on for example, code modifications or modification of the rules or routines of this platform infrastructure. And off-chain doesn't really have that. Off-chain is purely based on community governance, right? And within the, so the other dimension I use is delegation. So whether coin holders can lend their coins to delegate for them to vote, okay? So under the broader on-chain governance category, we then, I then have the direct on-chain voting and the delegated on-chain voting. The two subtypes of on-chain governance. And in this fourth quadrant, of course, it's not applicable to blockchain because it has delegation, but it doesn't use tokens to delegate. So it's probably more similar to a traditional hierarchy that doesn't really apply to blockchain. So here's the model. I hypothesize an overall positive relationship, the main relationship between sponsor ownership and the performance, because concentrated ownership enables organizational sponsors to more efficiently allocate resources to activities, and the centralized sponsorship also enables the incentives and the monitoring more effectively to promote financial performance, and the orchestration element of a centralized ownership is more likely to enhance financial performance according to the literature. And in terms of control modes, these are the two moderators we are looking at here. Here I use delegated on-chain governance as the baseline. So the assumption here is that delegated on-chain governance or delegation is assumed to have the optimal performance because it kind of balances ownership control with structural alignment. So on the one hand, the owners have their control over activities, over resource allocation, but on the other hand, the owner control doesn't get too concentrated because this delegation scheme also attends to different stakeholders' needs. And on the other hand, either direct on-chain or pure off-chain will yield the best. I mean, neither of the two models will yield optimal performance compared to delegation because direct on-chain is susceptible to the risk of plutocracy, right? The rich get richer and the rich makes all the decisions, which is the presumably not the most ideal model. On the other hand, off-chain can be very inefficient. It's more decentralized, but it's inefficient and it can take a long time for the community to make perhaps an urgent decision, right? A decision that needs to be, or a problem that needs to be urgently resolved. Okay, so that's the model. And let me jump to the results quickly. So H1, the direct relationship, is not supported, while H2 and H3 are supported. And it's probably easier for me to show you the interactions to visualize what's happening within each subgroup. So this interaction model actually shows a very clear cross-interaction pattern that influence financial returns. And this cross-interaction actually explains why the main effect, or H1, is negligible. It's not supported because they kind of canceled out with one another. And here, so if we look at the space where ownership is more dispersed, direct on-chain actually outperform the other two models when ownership is dispersed. And this, again, makes sense because it enhances the efficiency in decision-making when ownership is more distributed. But when ownership is more concentrated, delegation outperform the other two models because it strikes a balance between owner control and the platform alignment. And in terms of off-chain, it stays in between. It neither yields optimal performance it doesn't really yield optimal performance regardless of the concentration of ownership. Okay, so how can we interpret the results? Okay, well, first of all, I would like to highlight the fact that decentralized platforms, and more specifically blockchain-based decentralized platforms, are different. Okay, if we refer back to the literature, if we think about how we have focused on the orchestrating role of platform owners, platform leaders, and how we think that by orchestrating the platform, that's how we almost kind of assume that this is the only way or the best way to govern a platform. That model may not apply to the blockchain context. So neither a Facebook model or a Linux model, I mean the open source model, work the best for decentralized platforms. There's no one-size-fits-all governance design. And we really need to take both the ownership and the control element into consideration when thinking about governance, which is a huge issue in the industry. The industry wants to know how to best govern a blockchain, or how to balance decentralization and adoption. Right? There is a trade-off between the two, and some people say that we don't care about decentralization, but then why do you even look at the opportunity or the possibility of adopting a blockchain, right? And secondly, okay, sponsor ownership needs to be considered jointly. We talked about that. And the third point, okay, a tight coupling of ownership and control outperforms when sponsor ownership is dispersed. So by tight coupling, we are looking at the on-chain governance model, a direct on-chain more specifically, the one coin, one vote governance model, which tightly couples ownership and control. So that works better when ownership is distributed. And delegation works better when ownership is more concentrated. And a loosely coupled ownership and the control, which is the off-chain model, actually closely related to what we have seen in community governance. If we think about Linux, we think about how the Wikipedia model, right? It's highly distributed, but it's not efficient, and it's mainly in the blockchain context. This community-based model mainly use the cryptocurrency to work as an incentive for the miners or for the investors, and this, well, based on the result, doesn't really enable a most effective governance outcome. Here I come to the end of the presentation. I did make the result, like I did simplify the result a little bit so that we can have a bit more time for Q&A and the discussion. I hope that's okay with you. Thank you very much. I look forward to your questions.
So thank you, Ying. I know that Joachim has a question, so Joachim, please take it away. You are muted.
Yes, thank you, Hannah, and thank you, Ying, for the nice presentation. Super interesting. I was wondering about your hypothesis H1. I mean, in a similar context, or related contexts, sometimes the argument is that distributed ownership creates more trust and so may attract more contributors. So even you may secure a smaller piece of the pie, but the pie grows. Isn't that also a point coming in and maybe explaining why you can't find it supported?
Yeah, I think it's a great point, and it's totally likely that this centralized model can attract more distributors with a higher willingness to contribute and arguably more or better ability to contribute as well. But since how the performance outcome is measured here is based on financial returns. So to capture the effect you just described, maybe we need to choose a different performance measure. For example, the growth of the developers community, or the growth in code modification, like the number of code additions and code versus code deletions that take place on GitHub, right? To capture the increase or decrease in participation. And I think that's a great question that can be tested. If we're looking at the governance of innovation, like if we're looking at innovation outcomes or innovation-based outcomes, then yeah, that's totally, I think, a very interesting hypothesis to have. Thank you.
Just thank you. But just briefly, I mean, I could imagine that indirectly that also affects then financial returns. So your measure may be complemented with others, but it should also, or might also capture that effect.
Yeah. But for now, I think it's simply just cancel out because of the crossover effect of different control modes. Yeah. Thank you.
Okay, thank you. And Will Kong has also another question.
Thank you, Ying, for the great presentation. I'm just wondering how should we think about the analogy here, right, between the delegated governance, stake-based, to just stake-based governance, decentralized in general, as compared to the literature in voting. When we have, vote buying, I think Deco Jackson, Belinsky has a paper on that, and also quadratic voting in that literature, where they go beyond, one person, one vote. Is this comparable, or there's something fundamentally different when these things happen on a blockchain as compared to just regular casting votes? When people can buy votes or vote by more than one vote per person.
Yeah, I think that's so I've come across literature in the political science literature that talks exactly about what you just described. In terms of how a democratic system, how a voting system, when using delegation, can simplify the voting process, but also at the same time creates new problems of vote buying or corruption or other related problems. But unfortunately, my data doesn't allow me to analyze those aspects. But I think what you said is totally relevant and possible in the blockchain space as well. But I also suspect that due to the anonymous nature of how blockchain works, hopefully that problem can be mitigated by using the blockchain technology as compared to the traditional voting system.
Either mitigated or exacerbated, depending on how we use the anonymity. But thanks for the question.
Thank you for your question.
Okay. So I also have a question. So let me maybe ask the last question. So in your data, I mean your results are for blockchain organizations individually, but do you have a sense how they perform in competition? So, for example, entering a market that is mostly focused, populated by concentrated platforms, entering as a, is it better to enter as a concentrated platform as well, or is it better to enter as distributed platform? Can you kind of find those categories in your data and separate this effect?
Yeah, that's again another great question. My data currently doesn't. Well, actually, no, it doesn't really give me. I didn't include no, competition as a control variable. Let me put it that way. But I think it is possible with my current data if I aggregate the numbers and work out the percentage or the market competition outlook, how crowded the market is versus how yeah, I think it can be done, and I think it's a great suggestion. Yeah, for me to look at that as well. Yeah, but at the moment, this paper focuses on the design element of the organizations.
But broadly, it would be interesting to ask how, what is the optimal design in a given competitive environment, not in abstract. Okay.
Yeah, but I think competition would be another interesting, say, external factor, market level factor to include as well. Like under what circumstances is a platform best designed? Maybe on-chain governance is better suited for I don't know, highly competitive market as opposed to a different model for a less competitive market. Thank you for that.
Okay, so thank you very much. Thank you very much, Ying and Daniel and Semi for your presentations and insights. I found it very interesting, and I hope everybody else as well. Let me finish with an announcement about the next event at CBER Forum. This will be David. We'll have a webinar where Amy Whitaker will present her work on tokenization and art, and David Yermak will be hosting it. This will be held in 2 weeks on Thursday, November 4th, also at 11 a.m. Eastern Standard Time. So thank you very much, and hope to see you all in 2 weeks.